Build-A-Bug is a hands-on activity in the We Are Water collection on the STARNet STEM Activity Clearinghouse, and adapted from the activity of the same name from Utah State University Extension. In this activity, learners explore the fascinating world of aquatic macroinvertebrates, often overlooked but vital creatures that inhabit our freshwater ecosystems. In this video, we will explore their crucial role in maintaining a balanced aquatic environment, their remarkable adaptations, and walk you through how to design your own aquatic macroinvertebrate with the Build-A-Bug activity. Aquatic macroinvertebrates are small organisms without backbones that are visible to the naked eye. They include insect larvae, adult insects, mollusks, crustaceans, and many others. One key role that they play is as indicators of water quality. Their presence, absence, or abundance can reveal important information about the health of a body of water. These incredible creatures have evolved remarkable adaptations that allow them to thrive in aquatic environments. Let's explore a few of these adaptations. Blackfly larvae live in moderate to fast water currents. They gather food from the fast-flowing water using special brush-like attachments on their mouthparts as a sieve or filter. They attach themselves to logs, vegetation, or rocks by secreting a sticky silk fiber and anchoring themselves to a sticky silk pad using hooks on its abdomen or rear end. Once anchored on a rock or log, it can then filter food from the water by simply holding itself in place and letting water pass through its mouthparts. Water striders have several adaptations that help them navigate aquatic environments with ease. They possess special water-repellent leg hairs that allow them to stay afloat and not break through the water's surface tension. Their long, slender legs are adapted for efficient gliding and rowing motions, allowing them to move swiftly across the water. Additionally, water striders can adjust the angle of their legs to selectively adhere or detach from the water's surface. These adaptations collectively enable water striders to walk, run, jump, and hunt on the water's surface, making them highly successful in their aquatic habitat. Damselfly nymphs are a juvenile form of the damselfly, with several adaptations and behaviors suited to their underwater environment. They have elongated bodies that allow them to use a snake-like side-to-side motion to swim. Their bodies end in gills that allow them to extract oxygen from water, and their eyes are adapted for underwater vision. Damselfly nymphs are ambush predators, hiding among aquatic vegetation and using their extendable hinged jaws to capture prey. These diverse and resilient creatures serve as a crucial link in the aquatic food web. They provide a vital source of nutrition for fish, amphibians, and other predators, forming a delicate balance in the ecosystem. Scientists and researchers study aquatic macroinvertebrates to assess water quality, pollution levels, and the overall health of freshwater ecosystems. By monitoring these tiny organisms, we gain valuable insights into the well-being of our watersheds. The Build-A-Bug activity uses creative play to explore and learn about the adaptations of aquatic macroinvertebrates. Before building your bugs with learners, share photos or video clips of different species of aquatic macroinvertebrates. You can use the examples from earlier in this video and find more information about aquatic macroinvertebrates from the Utah State University Extension, the National Park Service, and the Stroud Water Research Center. Links to these websites are in the video description. Once you've familiarized your learners with some of the unique adaptations of aquatic macroinvertebrates, it's time to build your bugs. Your bugs could be as simple as a drawing, or you can build them using whatever craft supplies you have on hand. Challenge learners to come up with 3 adaptations for their bug using the supplies you provide. While you can build your bugs out of anything, it may be helpful to provide your learners with both structural supplies for them to build the body of their bug and more decorative supplies to build different adaptations and body parts of their bug. Structural supplies like craft paper, toilet paper or paper towel rolls, twine, or even balloons can make great body shapes for your bugs. If using materials like this, be sure to include tape, glue, or another adhesive for your learners to attach things to their bug as they build. Be sure to provide plenty of supplies that can be used to create a variety of different adaptations for your bugs. Modeling clay, pipe cleaners, googly eyes, buttons, pom-poms, feathers, and beads are all great for representing different adaptations. This activity can be facilitated with practically any craft supplies, so don't hesitate to provide learners with things like scrap paper, bottle caps, or other recycled supplies, and challenge learners to come up with creative ideas for adaptations these supplies could represent. The imagined bugs your learners put together are limited in shape only by their creativity. They might have a toilet paper body with large button eyes and extra large feather antennae to keep an eye out for predators while they gather food from the bottom of a river with their sticky and fuzzy pipe cleaner limbs. Or they may use large feathery oar-like limbs to drift from plant to plant, taking chunks out of their stems with their grasping mouthparts, while breathing from a collection of bubbles on their backs due to a lack of gills. They might even use long tendrils designed to attract the attention of other animals before inflating themselves into a balloon-like ambush predator to be feared throughout the pond. Whether building a bug model or simply drawing a bug on paper, invite your learners to think about how their made-up bug fits into the environment of a pond, lake, or river. Some macroinvertebrates like snails or leeches can tolerate higher levels of pollution than animals like mayflies. Ask learners, how would your bug react to an increase in pollution? An increase in temperature? A year with less rain than usual? Also, make sure they come up with a fun name for their bug creation. The implementation guide included with the Build-A-Bug activity on the STARNet STEM Activity Clearinghouse includes a printable bilingual table sign with instructions for the activity in both English and Spanish, making it an excellent passive table program for your library. Additionally, you can create easy take-home kits by printing the activity instructions and including them with supplies in a sandwich bag. Invite your visitors to take photos of their at-home creations to share on social media and tag your library.